Hi, so this is a Physics 6B Winter 2019 Pencast assignment, and the problem is for homework number 2, problem 1. So the problem reads, the figure given is a snapshot graph at time equals 0 seconds of two waves approaching each other at 1 meter per second. Draw 6 snapshot graphs stacked vertically, showing the string at 1 second intervals from time equals 1 second to time equals 6 seconds. So a few things I want to elaborate more on physics concepts are that a snapshot graph is a graph that shows waves displacement as a function of position at a single instant of time. So here we have the position axis, and then here is the time indicated. For a wave on a string, a snapshot graph is literally taking a picture of the wave at this instant. This problem demonstrates a physics principle of superposition. The principle of superposition may be applied to two waves whenever two or more waves traveling through the same medium at the same time. The waves pass through each other without being disturbed. The net displacement of the medium at any point in space or time is simply the sum of individual wave displacements. This is true of waves which are finite in length, wave pulses, or which are continuous sine waves. Now this problem in particular demonstrates destructive interference. Destructive interference occurs when two waves come together in such a way that they completely cancel each other out. When two waves interfere destructively, they must have the same amplitude in opposite directions, which you can see that this wave is traveling in the positive x direction and this wave is traveling in the positive and negative direction. And they have the same amplitude of 1. So for the first snapshot graph of time equals 1 second, so you have the same dimensions, and because it's moving at 1 meter per second, it's only moved up 1 position on each perspective side. You can note that the wave is still traveling in the same direction. So for time equals 2 seconds, so the waves have moved up 1 meter more. The dashed line indicates the individual shape of the original wave. The blue line that I've highlighted is the shape of the string. And you move up for 1 more second. And this is where the perfect destructive interference is demonstrated. So the dashed lines completely cancel each other out, the perspective waves, and you get a solid blue line across the entire x-axis. You move over to time equals 4 seconds. The individual waves do not get hindered from colliding into each other. They keep on moving in their original direction. So you have the dashed line of the shape of the original wave and the blue line of the string. So the waves keep on going, and remember that net displacement is still occurring. You move 1 more second, and now the waves have moved another meter further apart, and now their shape is more closer to its original form. They keep on traveling, and then at time equals 6 seconds, they are now separated from each other on the string, and they just keep on going in their same perspective direction, like the direction that they were originally going. And thank you.